On this question, we want to use the graph of y equals f of x to answer the question. On what intervals is f increasing, decreasing, or constant? So when we look at this picture, we see this graph in red, which is labeled up here as y equals f of x. And when I'm looking for the intervals of increasing, decreasing, and constant, what I'm going to do is try to look at the picture overall to start with. And what I do is I trace the graph going from left to right. And the reason why I do that is because in the definitions of increasing, decreasing, and constant, all of those definitions describe x sub 1 being less than x sub 2. So that's telling us to go from the smaller to the larger value. And so on the x-axis, the smaller values lie on the left. So I'm going to start on the left. And as I trace over this graph, what I'm going to pay attention to is the y values. These words of increasing, decreasing, and constant, these are words that are describing the y. So as I go trace through this graph, I can see that along this path, the y's are constant, they're not changing. So all of these y values are 4. Then the y values are decreasing along this section, increasing along this section, decreasing along this section, then increasing, then decreasing, then increasing, and then constant. So I want to label all of these intervals, and I'll do that with some different colors. So we said that this section and this section of the graph are constant. Then this section is decreasing. This section is decreasing. And this section is decreasing. And then we have some sections that are increasing. And so we can visually see on the graph where these different sections are increasing, decreasing, and constant. And when we write down, when we try to answer the question on what intervals, this question is asking us to state the x's, the intervals of x, where the increasing, decreasing, and constant are occurring. So when I look at those x intervals, I'm imagining this line being sort of projected down onto the x-axis, and where is that interval starting and stopping? So because of this arrow, it's starting at negative infinity and stopping at an x of negative 6. So we have an interval of constant which goes from negative infinity to negative 6. Now I've used open intervals because the definition in this book gives open intervals, but there are other definitions, other sources where the definition could include closed intervals as well. And a closed interval would be if you had a bracket on this negative 6 instead of a parenthesis. But this book uses open intervals. So we also have a constant interval that is over here that starts at 6, and because of this arrow goes on forever to infinity. So we have the intervals of constant being from negative infinity to negative 6, union with 6 to infinity. So then let's write down the intervals of increasing. And those are the blue intervals that you see. And remember, we're going to be writing down the intervals of x. So this interval of x starts at -5 and goes to -4. And then we have an interval of x which starts at 0 and goes to 4. And remember, this book uses open intervals, which is why I'm using parentheses on this. And then we have some intervals of decreasing. Those are in this kind of pink color. This interval will start at -6 and stop at -5. We have another one which starts at -4 and stops at 0. And we have another one which starts at 4 and continues on to 5. And I apologize, I've just noticed that I left off an increasing interval. So you can see this little section right here I left off. So there's one more increasing interval which starts at 5 and stops at 6. So if you're going to be answering this question in my math lab, pay attention to the blue writing next to the blank, because I believe it says to separate the intervals by commas. So you may be using, instead of the union symbol here, a comma between these intervals. So as our final answer, we have intervals of constant being from -infinity to -6, union with 6 to infinity. Intervals of increasing being from -5 to -4, 0 to 4, and 5 to 6. And intervals of decreasing from -6 to -5, -4 to 0, and 4 to 5. Determine if the function is even, odd, or neither. And we have f of x equals 5x squared minus 6 over x. So I've brought this in from our notes, which is some instructions I gave you on how you can determine if a function is even or odd algebraically. So what we're going to do is calculate f of -x. And then we're going to compare f of -x to f of x. If it is the same as f of x, we know that the function is even. And if it's the opposite of f of x, we know the function is odd. Now, the reason we know this is coming from the definition of even and odd. So from the definition of even, we get that f of -x equals f of x. So this calculation of f of -x is equal to, is the same as f of x. And then from the definition of odd, we get that f of -x is negative f of x. So that's where we get the opposite of f of x. So we're going to do that calculation, and then we're going to compare this to the original function. So let's calculate f of -x. We get 5 times -x squared minus 6 over -x. And that's 5 negative Now negative x squared is negative x times negative x. And a negative times a negative is a positive, and x times x is x squared. So we end up with this 5x squared minus 6 over negative x. Now this negative that we have in the denominator, so I'm just on the side over here for a second. When you have a negative with a fraction, you can write it in 3 different ways, and they're all equivalent forms. So if you have negative 1/2, you're allowed to write that as negative 1 over 2, and you're allowed to write that as 1 over negative 2. All 3 of these are the same, are equivalent. So this negative that we have down in the denominator, we can pull it out in front of the whole fraction and write it as negative 5x squared minus 6 over x. And what we notice is that this portion, 5x squared minus 6 over x, is the original f of x. So we have the opposite of f of x. So if f of negative x, that calculation that we did, is the opposite of f of x, we know this function is odd. So we do have an odd function. Now, just as a side note, this does tell us something about the graph. The graph of an odd function will have origin symmetry. On this question, we want to determine if the function is even, odd, or neither. And we have the function f of x equals x to the 5th minus x squared. So on this question, the way that we're going to go about determining if it's even, odd, or neither is to calculate f of negative x. And if that calculation of f of negative x is the same as the original function, we know that it's even. And if it is the opposite of the original function, we know it's odd. And we get that from the definition. The definition of even has f of negative x equal f of x. And the definition of odd has f of negative x equal negative f of x. So let's do that calculation. We have f of negative x equaling negative x to the 5th minus negative x squared. And then we're going to simplify. So on negative x to the 5th, we have an odd power. So that means I have an odd number of negatives. So it'll be a negative. And on negative x squared, that is an even power. So I have an even number of negatives, and this will work out to be x squared, and I'll carry down that minus. So I have negative x to the 5th minus x squared. Now when I look at this, I could factor out a negative to see if it is the opposite of the original function. But when I factor out that negative, which makes the opposite, this is not f of x. And so we don't have the opposite of the original function. And if we go back to this line right here, you can also see that this is not the original function either. This is not f of x. So we don't have something that is the same, and we don't have something that's the opposite. So we're going to put this in the category of neither. So I had a question come up of whether all the terms needed to be opposite in order for this to work. So in order for it to be odd. So when you look at this statement here, we have the first term being the opposite, but the second term is not opposite. So let's say this example was instead f of x equal x to the fifth minus x cubed. If it were that, when we calculate f of negative x, we would get negative x to the fifth minus negative x cubed. Both of these are odd powers, so you're going to have an odd number of negatives. So that will be a negative x to the fifth. Carry down that minus, and this is a negative x cubed. These two negatives in the middle will multiply together to be a positive. And now you can see that I have a positive here, but a negative here, a negative here, and a positive here. So that's the opposite on every term. However, we can also factor out that negative, and it will be x to the fifth minus x cubed if we do that. So we've got the opposite of f of x here. And so this would be an odd function. So on this question, we want to find the x-intercepts and the y-intercept of the function f of x equals 10x squared minus 6x minus 3. So I'm going to start with the y-intercept because that's always a little bit easier, almost always a little easier. And when we find a y-intercept of an equation, we're going to let x equal 0. I'm going to substitute a 0 into the function, and that gives 10 times 0 squared minus 6 times 0 minus 3. And 0 squared is 0, times 10 is 0. 6 times 0 is 0. And we end up getting 0 minus 3, which is negative 3. So this function has a y-intercept of 0, negative 3. Then we want to find the x-intercept. So to find the x-intercept, we're going to let y equal 0. And I don't see a y in my equation, so we have to keep in mind that f of x has the same meaning as y. So we're going to set f of x equals 0. So that gives 0 equals 10x squared minus 6x minus 3. And this is a quadratic equation. Now, I usually start to solve quadratic equations by factoring. So I'll try to factor this. And when I try to factor, I'm going to see that the factoring doesn't work. So the numbers that go here and here need to multiply to be 10x squared. The factors of 10 are 10 times 1 and 5 times 2. So it's either going to be 10x and x or 5x and 2x. I'm going to try the 10x and the x and see if that works. Now the numbers that go in the back need to multiply to be negative 3. And I only have one choice for that. That's going to be a 1 and a 3. I'm going to try that. And this is my guess for the factoring. And I need to check to see if it's right. And what I'm checking is to see if I get the correct middle term. I'm going to multiply the inside and the outside together. The inside and the outside are what make up that middle term. And that's a 1x and a 30x. And that is, these will be either added or subtracted. And 30x and 1x can't combine to make a 6x. So I know this is not right. So then what I do is I change it up. So I'm going to change this 3 and move it over here. So a 3 and a 1, that's 3x and 10x, and 3x and 10x cannot be added or subtracted to make that middle number of -6. So I'm going to try again. And this time I'm going to switch the 10x and the x to be 5x and 2x. So let's try. The inside is 6x, the outside is 5x. 6x and 5x can't be added or subtracted to make that middle term of 6x. So this is not correct. So I'm going to try one more time. I'm going to move this 3 to over here. 3 and 1. We're going to multiply the inside and the outside. That gives 2x and 15x. 2x and 15x can't be added to reach that middle term. So what I've done is I've tried every possible combination of factors of 10 and factors of 3 in order to create a factorization of this quadratic, but it doesn't work. So that means that factoring can't be used to solve this quadratic. So what's nice is that we do have a different method for solving quadratics that does work no matter what, and that is to use the quadratic formula. We also have another method we could use called completing the square, but we're going to use the quadratic formula. With the quadratic formula, you can take any quadratic, and a quadratic equation would have the form ax squared plus bx plus c equals 0. And you can find the solutions to that quadratic equation by following this formula using the a, b, and c that are the coefficients. And that formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to do that with our example. And in our example, we have 10x squared, so that means that a is equal to 10, minus 6x, b is equal to -6, and minus 3, so c is -3. And we're going to substitute these into the quadratic formula. So we have -b, a negative in the formula, and b is a -6, plus or minus the square root of -6 squared minus 4 times a is 10, times c is -3. And this is all over 2 times a, and a is 10. So this will give us the solutions to the quadratic equation, and we just need to use order of operations to simplify. So we've got negative times negatives, that'll give us a +6. Inside the radical we have -6 squared. -6 squared will be a +36. And then we have 4 times 10, that'll be 40, times a 3, that'll be 120, and that's going to be a +120. All over 2 times 10, which is 20. So if we continue, inside of the radical, we need to add those together. 36 plus 120 would be 146. No, 156 over 20. And then we're going to try to simplify the radical first. So we're going to try to simplify this radical. In order to simplify that radical, I need to know the factors of 156. So let me grab my calculator. I'm just going to get my computer calculator here. And let's let's see, I've got this calculator, and I'm going to do 156 divided by 4. Now, I chose 4 because 4 is a perfect square, and I know I can take the square root of a perfect square. The square root of 4 is 2. So we got lucky on our first try here because we got 39. So 4 times 39 is 156. What I would do next if 4 didn't work would be 9. So let me grab my calculator again. So I would have done 156 divided by 9. 156 divided by 9 doesn't work because it has decimal values. We wanted a whole number. And then I would do 16 next. 156 divided by 16. And that doesn't work either because it gives decimal answers. So hopefully you're seeing the pattern that I chose to divide by 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16. These are all perfect squares. So 6 plus or minus square root, and I'm going to rewrite the 156 as 4 times 39. And then we're able to apply this radical to both of these factors individually. So square root of 4 simplifies to be 2. Square root of 39 doesn't simplify, so I have to leave it. And then I have one more simplification that I'm going to do, and that is that we have a fraction. And we always want to write our fractions in lowest terms. So what I'm noticing is that 6 is an even number, 2 is an even number, and 20 is an even number. So I know that I have an even factor in the numerator and an even factor in the denominator. So I could factor out 2. That would leave me with 3 plus or minus square root of 39 over 20. And I can then cancel out a factor of 2, which would leave me with 3 plus or minus square root of 39 over 10. So this is an acceptable answer, but I've also seen it displayed in a different way. So I'm going to show you one more thing that you can do here. If you choose to, you can separate, this is now one big fraction. You could separate it into 2 smaller fractions. If you separate it into 2 smaller fractions, you would get 3 over 10 plus or minus square root of 39 over 10. And this is also an acceptable way to write those x-intercepts. So this quadratic function does have 2 x-intercepts, and those x-intercepts would be 3 over 10 plus or minus 39 square root of 39 over 10, comma 0. So let me zoom out so you can see everything. And we have found the x and y intercepts of this function. On this question, we want to find the equation of the line passing through the points 2, 3 and negative 2, 7. Write the equation in point-slope form, slope-intercept form, and standard form. So we are going to start, the first format that we're going to write this equation in is point-slope form. And point-slope form is y minus y1 equals m times x minus x1. And when we use this form, there's 2 pieces of information that we need to know, and that is the slope and a point on the line. The point is x1, y1, and the slope is m. And that's why it's given this particular name, point for the x1, y1, and slope for the m. Now we do have a point on the line. In fact, we have 2 points on the line, but we don't have the slope. So in order for us to use that point slope form, we need the slope. Now luckily we have a slope formula, and the slope formula is y2 minus y1 over x2 minus x1. So we can find the slope of the line given 2 points on the line. So I'm going to use one point as x1, y1, and the other point as x2, y2. And let's substitute it into the slope formula. So y2 is 7 minus y1, which is 3, over x2, which is negative 2, minus x1, which is 2. Let me just double check I didn't miss any signs. I have 7 minus 3 over negative 2 minus 2. Okay, so in the numerator that gives 4, and the denominator negative 4, so we have a slope of negative 1. Now that I know the slope, I'm going to be able to write that point slope form. So using y minus y1 equals m times x minus x1, I'll substitute in the slope of negative 1, and I'll use the point 2, 3. Y minus 3 equals negative 1 times x minus 2. So we have the point slope form. The next form that I'm going to find is slope intercept form. And slope intercept form is y equals mx plus b. So in order to write this in slope intercept form, I need to have the y by itself on one side of the equation. So that's what I'm going to do here. I'm going to get rid of these parentheses using the distributive property. Negative 1 times x is negative x. Negative 1 times negative 2 is positive 2. And then I'll add 3 on both sides to give y equals negative x plus 5. So now we've rewritten the equation in slope intercept form. Then finally, we're going to write the equation in standard form. In standard form, let's write this down here. Standard form is when you have ax plus by equals c. So the standard form, you're going to have your x and y term on the same side of the equation. So I'm going to start with y equals negative x plus 5. And I'm going to rearrange the terms so that the x and the y are on the same side. So let's add x on both sides. That gives x plus y equals 5. That is my standard form. So we've written all the different formats for this linear equation. And this linear equation passes through the point 2, 3 and negative 2, 7. Find an equation of a vertical line through 8, 6, through that point 8, 6. So in order to find the equation of a vertical line, we have to know about vertical lines. Vertical lines are really a special case of our equation. All of the other equations can be written in slope-intercept form, y equals mx plus b. But vertical lines have a slope that is undefined. So because the slope is undefined, you're never going to be able to come up with a number to plug into that equation to find the equation of this vertical line. So we really have to know what the equation of vertical lines look like. And the equation of a vertical line follows the pattern of x equals a specific number. Now in our example, we know that our vertical line must pass through the point 8, 6. So we're going to use the x-coordinate from that point as the number in our equation. So the equation will be x equals 8. So we can display this with a picture. We have the point 8, 6. Would be about right here. And we want a vertical line that passes through that point. And now if you think about all the ordered pairs on this line, every single ordered pair on this line will have an 8 as the x-coordinate. So no matter what, x is equal to 8. So that's why we get that equation. So the equation of that vertical line is x equals 8. Thank you for checking out my videos. Have a great day.